Dear student, welcome to all of you in my online maths video class. In our last video class, we discussed about the relation between arithmetic mean and geometric mean. Dear student, in this academic year 2020 and 21, arithmetico-geometric series is not in our syllabus. Therefore, we should discuss only that topic what is important according to our syllabus. According to our syllabus, the next topic is to find the sum of n terms of some special series. The sum of the first is that the sum of the first n natural number means 1 and sum of the square of first n natural number, and the third one sum of the cube of first n natural number. It means we have to prove that 1 plus 2 plus 3 plus 4 up to n is equal to n into n plus 1 by 2. This is the first one. Similarly, we have to prove the second, 1 square, 2 square, 3 square up to n square is equal to n into n plus 1, 2n plus 1 by 6. And the third one, 1 cube, 2 cube, 3 cube up to n cube is equal to n into n plus 1 by 2 whole square. We have to prove this part and this part. This is the last topic of our chapter sequence and series. After this, we will start the equation of the straight line, which is related to volume 2nd of the mathematics book. Before that, we should try to prove this value, that is the sum of first n natural number is equal to n into n plus 1 by 2. Dear student, here this can be written as summation of n natural number, or this is also written as k, where k is equal to 1 to n. This means this also and this means this also. So at the place of this we can write this up, and at the place of this we can write this also, and its value is n into n plus 1 by 2. We have to prove this. Here how we prove given series is what? 1 plus 2 plus 3 up to plus n. Okay, since this is in AB which is in AP means arithmetic progression, where first term A is equal to 1 and common difference, that is D, is equal to also 1. We know that since Sn is equal to n by 2 into 2a plus n minus 1 into D, we all are familiar with this formula. Then here n by 2, and the first term is what? 1. It is 2a plus, and here the value of n will be n minus 1 and common difference is 1. Here again we can write n by 2, and what is a? The value of a is also 1. The value of a means first term is 1. Then here we can write 2 1 is 2 plus n minus 1, okay, which is equal to n by 2 into 2 minus 1 will be 1, n plus 1, and finally we can write as n into n plus 1 by 2. In this way, here we can write sum of first n term is equal to n into n plus 1 by 2, or we can write sum of series from 1 to n is equal to n into n plus 1 by 2. Example. If we want to find the sum of 1 plus 2 plus 3 up to 20. Then it will be 20 into 20 plus 1 by 2. 2 tens are 20 and here will be 21 210. Okay. Similarly, if you want to find the sum of first 100 natural number, then how we do? We can write here 1 plus 2 plus like that 100. Then S100 will be equal to 100 into 100 plus 1 by 2. Now 250. Here 50 into 100. 100 plus 1 is 101. Now we should 0, 5 ones are 5 and here 5. In this way, in very simple way, we can use this formula to find the sum of first and natural number. Okay. Now we should prove the sum of the square of first and natural number, which is equal to n into n plus 1, 2n plus 1 by 6. But here we should use binomial theorem also. Now how we use? Let us see. Prove that 1 square, 2 square, 3 square, 4 square up to n square is equal to n into n plus 1, 2n plus 1 by 6. This is the formula for finding the sum of this one. Okay. n into n plus 1 and 2n plus 1. n into n plus 1, 2n plus 1 by 6. Okay. Dear student, we all are familiar with the binomial theorem. We use here binomial theorem to find the solution of this. We cannot prove this thing with the help of right hand side or from the left hand side. We have to start the proving part from the another method. So first of all, we should consider any value just k. Here k plus 1 whole cube. If there will be square, there will be take the cube. If there will be cube, there will be take power 4. Try to understand. Here k plus 1 raised to the power cube. On the basis of binomial theorem, we can very simply write. What is the binomial theorem? If it is a plus b raised to the power n, then what we write? nc0 a raised to the power n plus nc1 a raised to the power n minus 1b plus nc2 a raised to the power n minus 2b square plus like that. We use this method for finding. If it is done, then no problem. Very good. A plus b whole cube, you know, it's a expansion. A cube plus b cube plus 3ab and within bracket a plus b. But it will be better if we expand using binomial theorem. Then it will be 3c0 k raised to the power 3 plus 3c1 k raised to the power 3 minus 1 into 1 plus 3c2 k raised to the power 3 minus 2 and here 1 square plus at the place of n what we should write? 3. Again here 3c3 k raised to the power 3 minus 3 into 1 raised to the power 3. Or simply we can write here 3c0 k3 plus 3c1 k square plus 3c2 k plus 3c3. Simply we can write. Okay. Now we know that this is the coefficient of 3c0. What is the value of this? 1. We can write here 1 k cube plus 3c1 can be written as, what is the value of 3c1? Here ncr is what? Factorial n upon factorial r into factorial n minus r. So similarly 3c1 is what? factorial 3 upon factorial 3 minus 1 into factorial 1, or we can write factorial 3 upon factorial 2 into factorial 1. Finally, its value will be 3. Okay, here it will be 3k square plus the value of 3c2. Value of 3c2 also will be 3. Here it will be 3k, here plus 1. In this way, expansion of k plus 1 whole cube is equal to like this. Okay. Now you can, if you know the formula, so directly you can write this. So here at the place of this, directly we can write this formula. I just want to mention that from where this k, that is k3 plus 3k square plus 3k plus 1. Okay. Since we need a square, therefore we put only this form right hand side, or we can write here 3k square. It will be better if you write this one k plus 1 cube, transfer this to this side, minus k cube is equal to 3k square plus 3k plus 1. Get it? K plus 1 cube minus k cube, 3k square plus 3k plus 1. Okay. Now put k is equal to 1, 2, 3 up to n. Okay. If k is equal to 1. Okay. If k is equal to 1, then 1 plus 1 will be 2, and it will be 2 cube minus 1 cube is equal to k is equal to 1, then it will be 3 into 1 square plus 3 into 1 plus 1. Let this is 1. Okay. No need to write equation simply. If k is equal to 2, then 2 plus 1 will be 3, and it will be 3 cube minus, at the place of k what we write, 2 cube is equal to 3 into 2 is 5, because k is equal to 2. Here 2 square plus 3 into 2 plus 1. Similarly, if we take k is equal to 3, then it will be 3 plus 1, 4 cube minus 3 cube is equal to 3 into 3 square plus 3 into 3 plus 1. Similarly, we just write like this way. If we take n is equal to, k is equal to n. Now I am going to take value of k as 1. Then it will be n plus 1 cube minus n cube is equal to 3 into n square plus 3n plus 1. Now add this. Add. What do you do? Just add it. If we add, then what we find? If we add, then we find that, look here. Here 2 cube and here 2 cube. Plus minus. This and this will be cancelled. Similarly, here minus 3 cube, 3 cube. Cancel. Just next, there will be minus 4 cube. Then this also cancel by this. The next one. Similarly, here n cube. The second last will be also n cube. Minus n cube, and here cancel. Then finally, we get this value. N plus 1 cube minus 1 cube. So this is n plus 1 cube minus 1 cube is equal to, what we find now, 3 1 square, 3 2 square. Just add it. We add in this form. Take 3 common. 1 square plus 2 square up to plus n square. Get it? Very simple. Similarly, the second part, 3 1 3 2 3 3. If we take 3 common, then we can write here 1 plus 2 plus 3 up to n. Now the third one. Here only 1 1 1 added up to n. There is that. If we add 1 3 times, then value will be 3. If we add 1 10 times, the value will be 10. Similarly, if we add 1 n times, the value will be n. So here it is n. Getting? Now this can be written as Okay, up to this I think clear. Now let us see the next step here this side. Now what we can write here? N plus 1 cube minus 1 cube equal to 3. Getting? What is this? 1 square, 2 square, up to n square, and this can be written as sigma n square also we can write. Or we can write it sigma k square, k is equal to 1 to n. At the place of this, we can also write like this way. It means this is the simplest form for writing this value. Getting? Similarly, here 3, here also 3. Okay. Here also 3. Then plus 3, here sigma n. Because this is the expansion of first n natural number. This is the sum of first n natural number. 1 plus 2 plus 3 can be written as sum of n natural number. Symbolically, it is like this way. And after that, plus n here. Getting? Very simple. Now, we just expand this. N plus 1 whole cube minus 1 cube. So, it is n cube plus 3n square plus 3n plus 1 minus 1. 1 cube will be 1. Any an expansion of this, a cube, n cube plus 3n square plus 3n plus 1 according to binomial expansion which is explained earlier. It is the expansion of this value. Now we know that here this and this will be cancelled. Okay, and it will be 3 factorial n square plus 3 into factorial n plus n. Now we want to find the value of this. We have to prove this. So take this at one side. This can be written as 3 sigma n square and transfer this and this to that side. The next topic will be like this: n cube plus 3n square plus 3n. Transfer this to minus 3 into factorial n minus n. Okay, very simple. N cube plus 3n square plus 3n minus this and this. Okay, now the next topic, next step, n cube plus 3n square plus 3n. Now how we can write this? N, this can be written as n into n plus 1 by 2 minus n. Getting? Now here we can take common like 2 here, because denominator is 1 here also, and here also. Then it will be 2n cube plus 6n square plus 6n minus 3n n plus 1 minus 2. Okay, it will be 3 sigma n. Now transfer this 2 to this side. It will be 6n square, sigma n square. 6 sigma n square is equal to 2n cube. Okay, 6n square plus 6n minus 3n square. It will be 3n square minus 3n minus 2n. Okay, then it will be 2n cube plus 6n square minus 3n square. It will be 3n square. 6n square minus 3n square will be 3n square. And 6n minus 3n minus 2n, then it will be minus 5n, and minus 5n minus 6n will be plus n. So finally here we get 2n cube plus 3n square plus n. Okay, now take common. We should take common n. Okay, we should take common as n, then it will be 2n square plus 3n plus 1. Getting? In this way, 6 sigma n square is equal to n within bracket 2n square plus 3n plus 1. Dear student, this is the quadratic polynomial whose first term is 2n square, second term is 3n and plus 1. We can factorize this. Okay, the coefficient of this is 2, coefficient of n is 3 and this is constant value. If we try to factorize it, so we find that its value is n plus 1 and 2n plus 1. The factor of this is this, n plus 1 and 2n plus 1. Then, how we can write the next step? We can write the next step like this way. 6 sigma n square is equal to n into n plus 1, here 2n plus 1. This implies that sigma n square is equal to n into n plus 1, 2n plus 1 by 6. Or we can write 1 square plus 2 square plus 3 square plus n square means sum of square of first n natural number is equal to 1 by 6 n into n plus 1 into 2n plus 1. It is in this way we can solve the sum of square of first and natural number. This is the way of proving this. In question may be given the proof of this value also. Sum of first and term, prove that 1 plus 2 plus 3 up to n is equal to n into n plus 1 by 2, and similarly we can give the question on this basis also. The practical question is also may be given in your exam. Therefore, go through it properly. Now, the next is the sum of the cube of first and natural number. We will see after this.